Hi guys, welcome to C-Sharp course in 10 days using W3Schools website. My name is Dr. Shan and today is the day 3 of learning C-Sharp using W3Schools website as a reference material here on my channel called Learn with W3Schools. In last class, we talked about variables and constants, display variables, multiple variables, and identifiers. Today, we're going to delve into data types and typecasting. We're going to see how we use various different data types on this day 3, and we're going to talk more about typecasting as well. Okay, so with quick disclaimer, this is not an official W3Schools website tutorial, nor is it being sponsored by them. So now that's out of the way. Before we go further, if you still haven't subscribed and you want to learn C Sharp in 10 days with me, don't forget to subscribe, leave a comment, and don't forget to like this video. This helps and encourages the channel a lot. So without further ado, let's begin and discuss what are C Sharp types. So let's talk about data types. Now, data types, as explained in previous chapter, are basically connected with variables, and they tell our variables the what type of data is being stored with you or within you and inside the memory. Okay, so data types are basically defining the type of data that is stored in the memory. So when we talk about data types, basically we are telling our computers that either I'm storing integer in form of a whole number, or I'm saving a decimal number which is considered as a floating values, or I'm saving a character, a boolean, or a string. These are known as a data types in C Sharp. Integer being a whole number, double being the floating value or the decimal value, character being a single character with single apostrophe, whereas boolean is just true or false, any one value at the same given time. Similarly, string being a multiple number of characters in a double quotation marks. So the difference between a string and a character is quite important to understand, that a character is a data type that only stores one single character at a time. If you give two, it will complain. It only is able to store one character within a single quotation marks. Whereas when we use a string, we basically give double quotation marks and we enter a bigger number of characters here. Okay. So typically data type specifies also the size of the type of variable we are going to have. As we have discussed, the data types and variables also represent how data will be saved in memory and how much space is required by that variable or needed by that variable to store that particular data. So when we say integer, it basically means that it requires 4 bytes of memory space. It will store a number, but it will take 4 bytes of memory space. Inside your memory, whenever you declare an integer variable, it will take 4 bytes. Because it's going to take 4 bytes, the amount of data or the value that can be stored here is between this range. Okay, if any number, which is again quite huge, but still it has a limitation. If you any number bigger than this value, the system will crash and it will give us an error that the number is too big to fit inside 4 bytes of memory. This is how the memory internally works. Similarly, if in that case we will now use something called long. Now we haven't talked about long before, but long again is a type of number, or again is same as number. The only difference is it takes 8 bytes in memory. So now it occupies double the memory size as compared to integer, and that means that now it can host a very large number of integer value from minus to positive. Okay, so if you are storing and if you are creating a program that is a huge number, for example, you all have heard that at one point the YouTube like button and the views button crashed. Sorry, not the like button, the view count crashed the YouTube system to a certain point, because a particular video took so many views which was not able to hold in a particular variable data type, which was again a size Gangnam style video. That video got so many views across the world that the maximum value of a views that was allowed in that variable to hold was exceeded, and the system was not able to run. It generated error at runtime, and that's how we consider the YouTube crash. Anyway, then they fixed it and then they used a different factor for them. So if you need a bigger number, we go for long. Then we have something called float itself for the decimal value, which take 4 bytes in memory. Again, it saves decimal number. However, we also commonly use a double, which takes actually 8 bytes. Okay, so if you are using decimal number, if you just know using a small values, we recommend using float. Or if it's a whole number, we use integer because it holds a smaller number of memory size. The larger the number, the larger the type, the larger the memory occupied, the slower the system will be. For example, if you have 10,000 variables or let's say even 1,000 variables in your entire application, imagine how much bytes it would occupy. So every variable will occupy that much memory space. So that's how the memory space is determined, along with other factors as well. The variables alone will occupy a certain memory space. Similarly, we have a Boolean which actually takes just 1 bit. This is the smallest memory unit. 1 bit, it either be 1 or 0. That's why it is only able to store either true or false. The smallest unit of memory inside of a computer is known as bit. Okay, 1 bit, it holds either 1 or 0. So it only has true or false. Character, because it only contains the single character, it has 2 bytes in memory, and because it only has 2 bytes in memory, it can only contain one single character. Okay. Similarly, we have a string. String is 2 bytes per character, so it's basically combination of character. So depending on how many characters you have used in your string, it will determine how big the string is. So size will vary, because you can have 4 hello, you can have hello world, or you can have an entire paragraph here of multitude of characters. So the size is actually varying depending on how many characters you have. Okay, so that's why we say a general rule is that 2 bytes for each character, and then determine how many characters you have, you just simply multiply it. So do keep this in mind whenever we talk about data types. It basically is using memory space as well. So that's why we say whenever we're talking about data types, it's talking about the memory allocation as well, and we use this word continuously. Let's talk a little bit more about numbers. So numbers are divided into 2 groups. Integer types stores whole numbers, positive or negative, such as minus 1, 2, 3 or minus 4, 5, 6, without the decimal values. The valid types are integer and long. So these are 2 types that we use, integer and long. Which type you need to use depends on the value that's going to be stored here. If the value is just like within a small range, we always go for integer, because we know it's integer, it holds a number and it occupies less memory size. But in for certain situations, if you have to have a big number, go for long. Okay, so integer is just simply created as integer. My number, any particular number, whole number that you give is basically assigned to it. We have already talked about this. But when you use long, now you need to tell your system that I'm going to create a long. So for example, if I have a program long, my number, this is a bigger number, but then you need to use a capital L at the end. This is an indicator or identifier that identifies that this value will be stored in a variable that is of type long, and it needs 8 bytes in memory. Okay, even though if you are using, for example, if I create another variable called long, x is equals to 10, but I want to make sure this is a variable of type long. Okay, I will make sure I make it L. Only then it will properly allocate 8 bytes to it. If you just use 10, internally it will be considered as an integer, because this is just the 10 value. Okay, so system will say, hey, it's 10, only 10, so I'm just going to give it 4 bytes. Okay, so internally it will be considered as an integer having 4 bytes. So that's why we use this L for a specific reason, letting it know that even though I'm just using a 10 value, which is very small, but I want 8 bytes for it to be reserved, because in future this value will be multiplied, and that the number can exceed to a very large number. Okay, and then floating point again is considered as a decimal values. Whenever we need to use decimal numbers, we always go for a float or a double. The same rule applies, because by default the data type for decimal values in C# is double. For a float, for a smaller value of 4 bytes, you need to use F more commonly, letting it know that do not occupy 8 bytes, occupy 4 5 bytes for this only. Okay, and then we declare a variable, behave like a container. If it is double, we use a D here, letting it know that, hey, I'm creating a double, now occupy 8 bytes. Okay, so use float or double, which one we should use. The precision of floating point values basically indicate how the digits and the values can have effect, can have after the decimal points. The precision of floating point values indicate how many digits the value can have after a decimal point. So the precision really depends on how many digits the value can have after the decimal point. The precision of the float is only 6 or 7 decimal digits. So do keep this in mind. So this means that after the decimal, how many digits you need. If you need only 6 to 7, we go for float. If you need a more value, okay, so we use a double, because double has almost 15 digits that you can use after a decimal value, and that is how they determine whether we go for a float or a double. So for example, if you are printing a complete pi value of pi, which is again, if you bigger value 3.1.555 blah 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 numbers, so 3.1.33, I think something is that, right? And you want to print the whole value, so we go for double because we want to ensure that the maximum digits after the decimal are there. So it's always safer to use a double for most calculations. That's one major reason. Okay, you can use scientific exponential notation with float and double as well by using this e symbol in between. So a float point number can also be a scientific number with e to indicate a power of 10. Okay, so we say, for example, 35 exponential notation 3 means e to power 3, and then we provide f again if it's f, or if you are using double, then we use e 4 power d. Okay, this indicates that this number is 12 power 4 in this case, and 35 power e, and then you get that value represented here. If you print it, it will solve and print the actual answer for that. Understand? So this is again one very useful feature if you are going into mathematics, creating a mathematical programs for some reason, and you want to put data in exponential notations. This works fine. Okay, Boolean, as we said, is a very simple thing, true and false. Why we need them? Actually, we have a Boolean data type. It only stores true and false. Understandable. But actually, Boolean is a very, very important data type that is more prominently used with if-else looping conditions, because it holds a value called true and false, and this is the value that is needed by if, else, switch, and while and for loops. We're going to talk more about this in this section. But do remember, whenever we do a simple calculation in our system, the data type matters, even though you don't specify. So for example, if I come back to this code, or let me just say in this code, for a simple reason, I have my number and I do plus, for example, 10. Okay, so now what happens is that the system will read my number, add 10 to it, and the answer is actually saved in the memory again before it is printed on the screen. So when we have that thing, that when we want to save that answer, even though we are not doing anything with the answer here, we just want the answer to be printed, it is not directly printed on the screen. That answer is actually stored in the memory somewhere, and the system needs to know that what is going to be the type of this answer. So in this case, the answer will be of type long because we are using long, right? Similarly, integer, byte, float. In that way, and where there are certain expressions that we will be using, and I will talk more about that in operators, they need the value in form of Booleans, and they need to tell our system that this is a true or false value. Okay. Then moving on, we have character data type. Character again is a data type that holds a single character in a single apostrophes. Okay, single quotations as we call it. Any character, any number, any value will be behaving as a character occupying 2 bytes in memory, and they are used inside single quotation marks. Again, quite useful in various different situations. A string, one of the most commonly used data types, is basically containing multiple characters, alphanumeric, escape characters, special needs, special characters, anything that are written in words inside the inverted quotation marks. So do note that whenever I use this string here, this is printed in form of string. If I come back here, I have a string. When I use even the system dot print inside this console dot write ln, I use hello. This again behaves like a string, and if I add plus to it, now basically what we are telling that this is a string. So this string is again stored in memory before it gets printed, because everything is processed inside by processor and then it's stored in the memory before it gets printed on the screen. So this string also needs to be told to the system that, hey, I'm printing a string. So the system or the compiler needs to know what type of data this is, and for that there's a specific understanding within a system that I'm using a string data type. Okay, so even though you may not directly use it, but internally systems always use these data types as well. So any number of characters in and double quotation marks behaves like a string, and we're going to talk more about the string specifically within the strings chapter, where there are various different ways, methods that are available that we use to operate on this string. Okay, so this is data types. Now connected to a data type is an important topic called casting, which is absolutely essential that we associate with our data types. Okay, casting means converting data from one type to another. Okay, that's the common way of dealing it. So typecasting is when you assign a value of one data to another type, i.e. you assign a value for float to an integer. Now float is a decimal. integer is a whole number. How can I assign a decimal value to an integer data type that can only store what we call a whole number? Or in that case, for example, a character can be stored inside an integer. Can I do that? I don't know, maybe. So this is what typecasting does, and it occurs regularly in our coding, especially when we're taking inputs from the user. Usually we don't know what values they enter and we need to process them, and we need to know the type of it. So typecasting is a phenomena that deals with assigning value of one data type on another data type. Okay, so in C Sharp there are two types of casting. One is known as implicit casting and another one is known as explicit casting. Implicit casting is known as casting that is done automatically. In other words, the assignment of data from one variable data type to another variable data type is done automatically, and we don't actually have to worry about it, but we have to know that this is happening. Okay, so converting a smaller type of data to a large type of data is considered as automatic casting. What do we mean by smaller type? Remember, we discussed about the data types memory size. So this is where we determine a smaller type to a larger type. So character is the smallest type. It occupies only 2 bytes. Because it occupies 2 bytes, the character can easily be assigned to an integer or a long or a float or a double, a larger memory size. Because it occupies 2 bytes means it has only 2 value. A 2 value can easily be adjusted into a larger memory size. Okay, so this is where our automatic casting takes place. So it shows you here, character can easily be assigned to an integer, and this automatically done because 2 can easily go inside the 4. 4 spaces are available, we have 2, can easily adjust. Similarly, integer can also be assigned to a long, meaning integer is of 4 bytes, long is of 8 bytes. I can easily automatically assign 4 byte value to an 8 byte value. And then similarly, a long can easily be assigned to a float or a double. So this is a hierarchy that we follow: character, integer, long, float, double. However, what if we reverse it? Now double is 8 bytes, float is of 4 bytes. So what happens if a larger memory size value is assigned to a shorter memory? Similarly, long is of 8 bytes, integer is of 4 bytes. What happens when I assign a larger memory size to a smaller memory size? And then goes from integer 4 bytes to character byte. That also means, again, this is not the exact the sequence, is just letting us know the hierarchies, meaning that I can have long assigned to a character as well, but long is 8 bytes, character is 2 bytes. So what happens now? Where the remaining 6 bytes of data supposed to go? So this is the problem. So that's why it does not happen automatically, and we need to do something called explicit casting. Okay, let's see a few examples of implicit casting first. For example, I declare an integer, my integer 9 value. So this my integer has been declared. We know integer occupies 4 bytes in memory. Then we go to double, is an 8 byte variable. So my double, and I assign the value of my int to double value. So this is a variable. This will have a value of 9 in its memory, occupying 4 bytes. So now what we did here is we said, hey, read this value and assign that value to this double data. Because double is 8 byte, this is 4 byte, this is automatically done. Automatically casting is done here, and I don't need to worry about it. Okay, so this is what we mean. We can easily assign integer to a double value without any problem. And then when we print the value, my integer will have value 9 and double will also be 9 because we have assigned the value of integer here. Explicit casting is when we explicitly need to tell C# that, hey, you need to do this conversion. And the way we do it, there is, for example, I declared a variable double. I have a 9.78 value. I created an integer, my integer is equals to, I use the same technique that I did with implicit casting, but this time we use parentheses integer. These parentheses integer is a very simple way of doing explicit casting. Means now we are telling that the value of this double, which is 8 bytes in memory, having 9.78 value, needs to be converted into a 4 byte value and then assign it to that 4 byte variable. This is a very simple way of doing casting. So we just use parentheses and the data type in which we want to cast to. So when we print the value, again, the first double will print 9.78. The integer, because is only supposed to be whole number, it will remove the later part. Okay, the decimal values are lost and we just get the 9 value. So there are various different methods to do that. Okay, so type conversion method. So it is possible to convert data types explicitly by using some of the built-in methods, such as convert to Boolean, convert to double, convert to string, convert to integer 32, integer, and convert to integer 64. So for example, if we have integer, double, and a Boolean variables, you can use convert. Again, note C is capital. To string, T is capital, S is capital. C sharp is case sensitive, so we need to be aware of it. So now what we're doing is we are using built-in methods to convert integer value into a string form, or an integer value into a double form, or a double value into a 32 bit integer, or 32 bit basically means 4 bytes. Okay, so I hope you know this from programming. From general computer, 8 bits is equals to 1 byte. So 4 bytes would be actually 32 bits. Okay, so this is where the 32 bits actually come into play. And then we can say convert to string my boolean. So my boolean will be now converted into a string value. Do remember that this convert represents a class name dot a method that exists inside this class name, and then we are passing it an argument of this value. So this is known as an argument, passing a value by an argument to this method that exists in a dot convert class. Understand? So we have a class that's already doing all these tasks for us, just like class program. So this is a class that we create on our W3Schools website called program. Similarly, there's a built-in class called convert. It's automatically there. We are already using it. We don't have to tell anything to our program to do what. It's by default imported. So this convert class contains a methods called toString, and we are using that method to convert our integer into a string form. Okay, so this is what we say, that there are built-in methods that you want to do that. We would talk about how to create our own custom classes and custom methods later on in methods and classes chapter. So do stick around. Okay. Okay, so once we have done this, let's do some real world examples of this thing. So let me just close everything else. Close. Okay, so for example, if I reopen this, we have a basic program already written for us. Once we do that, let's talk more about what kind of programs we can do for that. So for this, I have already created a simple program list, which is, these are some programs I'm working on, and I will hopefully by the end of this course I will share these programs with you so you can do these practice tasks and submit the code, or discuss with me if you are having any problem with that. Okay, so okay, let's just start with this. So first of all, the first program is write a C# program to input two sum of numbers. Very simple, very easy, very basic. How do we do that? The idea is very simple, as we all know. I'm going to use Word here, and my idea would be that I create an interactive manual where you actually save the code with each task yourself. So it will be like a worksheet kind of a thing where you solve it on the paper. You can use the W3Schools editor, or I will share a link of another editor called C# Online Compiler. If I open it, you can use this one as well. This is also works perfectly fine, no problem with that. So let's just use again this one compiler and try to create this simple program for us. So it says that the basic idea is again here that we need to write a C# program to print two numbers. This is our exercise number 1. Let me just copy this and let's just go to our online compiler and comment places. So this is our exercise task number 1. We need to do that. How we supposed to do? Well, the basic idea is very simple. We need to take two numbers and add them together. As simple as that. But you need to write something called using system. Okay, so as we know that every code has to begin with this thing, so we need to write this, such as using system. Okay, and then we use something called namespace, and in this case I'm using let me just use my name as my project name, C# block start block close. Every code needs to have that. Then we need to write a class name, so we write a class name, and we can say, for example, exercise 1 block start block close. Okay, so this becomes our basic boilerplate. Then we need to write something called not stack, static. We need to write void with capital M, bracket start, bracket close, and we used to write something called a string, and then square brackets for defining an array, arguments, block start, block close. So now this becomes our boilerplate, and every C# code needs to have that. The reason we want to do this separately from W3Schools, that we don't use this code, we try to retype it. The more you type from start to end, the more proficient and you understand how things are working within Maya. That's how the best way to practice is. So once you write this, now the question is very simple: print sum of two numbers. Now it can be that I can say, hey, listen, okay, if that's the case, let's just take integer and number one is equals to, this can be, for example, 20 semicolon, and then I can say integer number 2 is equals to, for example, 30, and then I go, hey, listen, I know to print the output I need to use something called console dot write line, 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 bracket star, bracket close, inverted quotations, and I can say the sum of number 1, which can be, let's just use plus here and say NO1, which basically will represent number 1 here. Let me delete that. Okay, so I can say the sum of, or if you want to print this thing, just skip it, the sum of number is, and what is it, we can write here. Let's just use it in terms of console dot write and then print semicolon, and then I can write, hey, listen, console dot write, and I'm using write, not ln, because I don't want this to appear on the new line. Whenever we use write, also works fine. We've talked about this. It will basically print the answer on the same line. So now we come here and we can say the sum of number, and we get plus number 2. Okay, so this is going to print number 2. Don't forget to give semicolon, and then again I wrote console dot write, bracket start, bracket close, inverted quotation start, close, and I can say is, and then I can go here and just print this thing plus, and I go, listen, 20 plus 30, oops, and then give a semicolon here. But the problem with this is, now if I execute this code, is a compile time error, right? So the compile time error says that we are expecting some issues, 6 errors in this code. Whoa, why 6 errors? What the hell? Unexpected symbol underscore, there's no underscore in my code. Why is it giving me, okay, see this underscore here. So this symbol here, the minus sign, we have used exercise -1. Because of this small thing, it has generated like tons of things. So minus is a reserve word, it understands this is supposed to be there. So let me just remove it and say exercise 1. I can use underscore though, okay, not the dash sign, underscore, this under 1, this should be fine. So if you want to use this, underscore should be fine. And now if you run the code, hopefully there should be no error. Okay, so don't use minus as a name, as a variable name, or as a method name formula. Minus, plus, these are considered as special symbols, more prominently reserved symbols as we call them, so you cannot use them. Anyway, so exercise 1, basic boilerplate, integer number 1, integer number 2, the sum of number 1 and the sum of number 2, and because we've used the write method, see this, the output is on a single line. That's the beauty of it. This is exactly what we want, and we can write the entire expression on a single line as well. Okay, but just to simplify things, we wrote it in different console statements. So the first thing we got is the sum of, now the number 1 value is 20, so we got 20 printed here, and 30, which is basically the sum of value here. Now the reason it's showing us very nicely as well with the spaces is because if you note, I have given it spaces. So off, after this I have given a space, then inverted quotation marks. Okay, and that will create a difference in your output. So for example, if you just close it like that, like mostly we do, and we write and then we close this like this. So because now we remove the inverted quotations, spaces before the inverted quotations, see this, the number appear together. Okay, so we just need to be a little bit intelligent. If I want a space after off, I give a space after off. I need a space before and, I give a space before and after and as well. And then similarly before is and then after is as well. So these spaces within the inverted quotations do create an important aspect. Finally, the major difference is that we get the answer 2030 because we have done plus 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 plus. Again, why we got that? We should have proper 50 answer, right? But we have talked about this. The inverted quotations always represent a string, and when you add a plus to it, it means you are joining two strings together, or you want to join something with the string. So when you have a inverted quotations plus 20, it means that you are joining these two strings together. And then when plus 30 means that now it's joining the rest of the string together. So actually this is joining the strings, which technically we use the term concatenation. Okay, so that's the whole idea. Now if you want to do this, there are two ways of doing it. First, you use the brackets explicitly. This will make sure that you have a higher precedence. Brackets has a higher precedence. It will make sure that the brackets gets executed first. So 20 multiplied by 30 will actually be executed first before it is concatenated with the string. That way it will do the mathematical calculation, because now no string is involved on within the parentheses of, so it will say 20 plus 30, 50, whatever is the answer is 50 will now be concatenated with this string, and we should get a result perfectly fine. See, 50. This is the one way of doing it. Now the second way is, usually we do is we create another variable integer ans is equals to, and we say number one, no1, and we do plus, and we can say no2 semicolon. So we create another variable and we save the answer in that variable, and now we can write console dot write bracket start bracket close inverted quotations, and we can say the new answer is space plus, and now we just print the value ans. Okay, so this way it will basically ensure that we get the output on the new line. So if I run the code, we get an error. That's because it says compilation failed, one error, and somewhere it is doing this. So do also understand how to solve errors, because you will be coming and getting more errors. So when we read this, it tells us there is one error, hello world css, this is the error code, and it is telling us to a certain extent that a semicolon is expected, and which we note here I've missed out the semicolon. So most probably it will tell us exactly where and what line of a point we have. So here, see this, it says 20. This is actually the line number on which it's expecting an error. If you go here, line 20 is actually these brackets here. So if there's no semicolon, it assumes that there is no this statement is still continuing and there's no break, and then it goes here and it finds a closing bracket. So actually the problem the compiler finds is at this point. So that's why it's giving us a 20 number. So it gives us a roughly idea where the error could occur, and we can find. So if you have like 10,000, 20,000 lines of code and one semicolon missing, if you don't know the number, then it becomes difficult to find exactly where we had the error. Anyway, once this is corrected, the answer is 50. What if I want this answer to be on the new line? Okay, well, there are two ways of doing it. First is this one, \n. Okay, backslash is known as escape sequence. To add a new line, we wrote this as a \n, and \n is considered as a escape character or a special character, which adds this new line feature within our code. So now we have this new line added here automatically, even though we use a write method. But if you want this, the second method would be that if you want this to appear on a new line, you can use write ln before its previous statement, because write line will add a new line after the output has been generated. So after this output has been generated, a new line will be added, and then this statement, even though it would be write, will always be printed as a new line. So if I write a line before this statement, because I want a new line here, so the previous statement I had a write ln, I want it on a new line. Now if I run the code, see this is on a new line. So you can use write line. So it will ensure that after this, it will add a line break, and the next line that would follow would automatically be on a new line. Okay, so that's what a line does. However, if you still want to do this, you can use \n, and then you can run the code, and now you see there are two lines of spaces here. So that solves our task number one. Let's just come here, and I will usually love to do this. This is the idea, Control C, come back to your Word file, and I have solved it. Okay, so now I can say solution. Okay, as I said, I'm working on this book, so hopefully I will try to finish it in time. I can paste the code. Hang on, Control Z, Control V. Okay, okay. Now I have this code created for me, and let me just add some tab. And I was supposed to format it, so sorry about that. So let me just make it a little bit smaller. Anyway, so this basically solves our task number one. Let's move on to very quickly task number two. Task number two says write a C# program to print the result of dividing two numbers. So I have this new page. I open the code again. Let me just delete this, comment, write a C# program to do the dividing two numbers. Okay, so this is our task number two. Now for me, I'm being a little lazy, so do excuse me for that. I'm just copying the whole code. Control C and Control V. I will rename it to exercise number 2, since I just need to divide these two things together. Okay, I'm not worried about too much about any other thing. So it's almost the same task except the division value. Now I divide it, and same answer can go for here as well. Okay, divide it, and instead of sum, I will just change it to divide. And now if I run the code, the divide of 20 and 30 is 0. Okay, where is 0? Let me just do this. 20 divided by 30, obviously the answer will be in points, and this answer is going to show us in 0 values. So let's just make it more convincing. So I can say, hey, 30 divided by, for example, 4, or let me just make it 5 for fun's sake, divided. Now answer is again 0. Why is 0? Because we use 20 here. We didn't use number 1 here. So we say number 1 divided by NO2. Run the code. Now answer is 6. Finally. Phew. Okay. So previous mistake. So the previous code we had, actually, we even created the variable, but stupid me, we use the values directly. So actually for this, the perfect answer would be number 1 plus number 2. All right. So make sure we update that in our system as well. So this is supposed to be that. And then if I go inside the division, now I divide it. Use the same value. So whatever answer you have, you run this code, you get 6 in this case. So for example, if I make it like 60 and divide this by 3 and run the code, so the divide of 60 by 3 is 60. And then you can print whatever you like. So once you have this code, very cheekily, I copy it and I go to my Word file and I say, hey, I did that. So I can say SOLUTIN solution. This is solved, and I put the code here. Let me just add it. Oops. Just like this. Okay, so this works fine for us. We have our code. Let me reduce the font size a little bit so it's more readable. So task 2 now complete. Now let's get into a little bit more deep, and we said create a C# program to print the result of the specific operations. So if we have such kind of complex mathematical operations and we want to perform the result on them, how do we do that? So now things get more interesting. Okay, so first thing is first, again, if I copy this line, or we just copy the whole thing. Oops. Control C. Let's just create a new file, open my one compiler and kill everything. Comment, just paste the task number here. This becomes our default code. Now, again, as writing this, I will try to do exactly same as we did previously, meaning that we will try to create the code from scratch and we try to work with that. So we will be using system semicolon. So we know what we're doing. We will be using namespace, and I'm going to give a same namespace because everything for me in this case belongs to same project. CS block start block close, bring it down, class, and then this can be, for example, exercise 3 without the dash. Remember, dashes are not allowed. So now we have exercise 3, and every code needs to have static, STA, static, void, M capital main, bracket start, bracket close, string with a small s, square brackets indicating an array, and a variable name, okay, which can be any variable name for that matter. And then we're going to give curly bracket start, curly bracket close. So this becomes our boilerplate code. Now it says, what do we need to do? So if we jump back to our program, here one, so we need these kind of outputs. So let me just copy this and come back here. Let me write a multi-line comment. Oops. Steric and steric backslash. Multi-line means that I have a multiple lines of comments and I don't need to use backslash in front of everybody. So I just put them here. So now these are the expressions that we need to write the code to generate. Okay. And then similarly, there are several ways of doing it. It doesn't exactly say that we need to create variables or data types, or we want to apply operations on them, or so on and so forth. It just needs to do these mathematical calculations. Since the program is not so specific and we just want these calculations to occur, let's do it in a very simple and easiest manner. So we're going to do, hey, system, console. We're going to say console dot write line, bracket start, bracket close, and now we want the answer to occur. So first thing is I will use inverted quotations. I will copy this, Control C, Control V, and I will use the ANSW answer of this is equal to, and then I'm going to use plus, and then I'm going to use the same expression. So I can, because now this is a mathematical expression, and the problem I just mentioned, that if you are writing a mathematical expression with a plus of string, it's going to concatenate. So what we need to do is we need to add brackets, exactly. And now we're going to use the same expression. So -1 space plus 4 multiplied by 6. Hit a semicolon. Okay, let's test this program out. Hit a run to see if everything works. So we get that the answer of -1 plus 4 multiplied by 6 is equals to 23. Perfect. How did it become 23? Again, you need to understand how expressions are being evaluated inside C Sharp. As I talked, when we write 6 multiplied by 4, the multiplication is always done first. If you have -1 plus 4, if you solve this first, now the answer would become completely different, or can become completely different, depends on how you write in expressions. So in an arithmetic setup, a multiplication is always executed first because it has a higher precedence. Similarly, brackets in fact have a highest precedence. Even with above multiplication, we have a brackets. So if I need to do this as a subway, so for example, if my expression required me to solve this thing, now this means that I have put them under parentheses. This becomes parentheses, and then outside it are more parentheses. So do follow it. We have this thing. Again, this is a standard mathematical expressions. If you go for basic mathematics, you would have come across using multiple brackets. We use the same brackets in multiplication as well for solving any standard regular expressions. So here parentheses has these round parentheses, round brackets have a highest precedence. So whatever is inside the innermost brackets would be solved first. So now here it will gonna solve this first. So if I run the code, okay, now see the answer is 18. See the difference? So now the answer is completely different as compared to previous 21. So if you, let me just copy this, if I show you in a better way. Control C and Control V, and if I remove the parentheses here, and remove the parentheses here, and in fact if I put parentheses in this point to make it more evident what exactly we want to do, and now run the code. So if you use parentheses, this parenthesis gets solved first, and then whatever is the outcome of it is multiplied here. Okay, but if you don't use parentheses, now what happens, multiplication is automatically done first because of its highest precedence. So multiplication will be solved first, then whatever is the answer of this multiplication, 6 multiplied by 4 is 24, or 6 4s are 24, then -1 will be used to subtract, and 23 is obtained. Okay, so that's the difference in terms of operator precedence and which expression gets to evaluate first. Once we are done with that, let's move on to the second expression. It says console dot write line bracket start and then inverted quotations, and I again put the same thing, the answer of, and this time we have this expression. See this, now we are using parentheses exactly in the same manner. So it is telling us to, what if I use 35 plus 5 and then mod 7. This mod again is known as a remainder operator, or percentage is known as a remainder operator. So it is going to take this sum of amount and going to divide with this thing. So if you write this expression in our syntax, so we're going to say is equals to, and we hit plus, and then I'm going to paste the whole expression again. So now what it's going to do is, it's going to do this parenthesis first, and whatever is the outcome of this parenthesis would then be used with this percentage to find the remainder, and then whatever is the remainder is going to be attached here. So if I execute the code, it says semicolon expected at line number 22. So this is 21, 22. This is not there. This one is here. Okay, so let me re-execute it and see what we get. Now we get the answer 5. Okay, why is there 5? Because 35 plus 5 becomes 40. Whatever is the answer here is then remainder is being calculated for that. Then 40 divided by 7 means we get, I think 40 divided by 7 is 5, right? And there is usually only 5 as a remainder is given. So we get the 5 answer. Perfect. Perfect. So that solves it. Okay. And I have a plus here. Why did not it add the answer for one this and then did the modulus? Again, if I use this, for example, if I use 7 here, plus 7. Okay. In fact, Control Z, oops, modulus, and let me just copy this code again, come back here, paste it, and then use plus here. Now tell me what will be the output of this code. Even though we are using parentheses, but we have a plus here and we have a plus here, and we just talked about that when we are attaching a string with any number, it's going to concatenate. What happens now? Will I get still the 5 answer, meaning the plus is done here, and then 40 plus 5 means 45 I should get, right? So I should get a 45, or will I get 5, or I mean, how the answer is going to appear? This way. Why this way? Because we say plus 35 plus 5. Because these are inside the parenthesis, so it has a higher precedence, so they become 40. Then this 40, because now it contains plus on the left hand side and plus on the right hand side, so it's going to start from the left, and this 40 is now concatenated with this string. So we get 40 plus 7 is now, hence 7 is going to be concatenated with the remaining part of the string. So the answer becomes 40 plus 7. Whereas here mod 7 is there, and these are typical questions that we ask people in interviews, in exams, especially whenever I have a questions in MCQs kind of a thing, that what would be output of this thing, and it looks very simple, but it's a very, very complex thing that we can do. Okay, it can be very tricky to understand exactly what's happening, because plus all have equal precedence. So parenthesis has a highest precedence, so first parenthesis being solved, then it's being concatenated or joined with the string, then whatever is the outcome of this whole expression is later on being joined here. But at this point, mod has a higher precedence. It's not because we have an expression here, it's because modulus has a higher precedence. Remember, parenthesis comes first, so it solves the parenthesis. Then it needs to make decision: do I need to perform modulus here, or should I perform plus here? Now the decision. So internally, it's automatically always gonna perform the modulus first, because mod has a higher precedence as compared to plus. So in this case, this was solved completely first. Similar to this thing, this multiplication is done first. Understand? Perfect. So that's why if you use plus, we only get the 7 here. Okay, so answer becomes, for example, 407 here. For this guy, the answer becomes 5 here. So that's the major difference. Same thing here. If I go, the answer is 23. And if I put the answers down, so that if I copy the code, I know exactly, I don't have to run it, and we get the answer. Okay, the answer here is actually 18 concatenated with this string. Finally, let's just go for the divide. And we say, all right, console dot right line, bracket start, bracket close, inverted quotations, and I wrote the answer of now this expression, control C, is equals to, come here, add a plus because we need to join the string, control V. Now what's going to happen? If I need this expression to be solved as per your understanding from here, I think you should be able to answer that the first thing we need to do is we need to write this entire expression in brackets for it to solve, and then whatever is the answer of this expression would then be concatenated with the string. Second thing we could do is we could use this entire expression in a variable as well. So we can have, for example, a double value, and we can say ans answer 2 or answer 3 for third expression is equals to, and we do control V, hit a semicolon. We could do this as well. What this will do is it will solve the entire expression and put it inside the answer, and then we can use the double variable here as well. We can easily do that, or in this case we can directly use this expression. This should not be a problem. But now how this expression is going to be evaluated? Because it has a multiplication, it has a division, it has a -4 value, it has a plus as well. Now what we're going to do, how we are going to solve this expression, or what should be solved first? So yes, as per previous thing, the operations of -4 and multiplication are going to be performed first. Okay, so this expression would basically be evaluated in a way that -4 multiplied by 6 would evaluate first, because multiplication has a higher precedence. Second number, whatever is the outcome of this expression, will then be divided by 11. So this will be executed second. Then whatever is the outcome of this expression will be added to this 14. Hence we get the final answer, which then will be conjoined, concatenated with the string. So you think that you write a simple expression, but internally this is how a computer system is supposed to work. They automatically take the multiply and they say, hey, this is a higher precedence, and it will break it down and it will execute multiplication first. Then whatever is the answer is going to be divided and then plus. Okay, so let's just run this code. And this is what we get. The answer of 14 plus -4 multiplied by 6 divided by 11 is 12. Okay, so we get a 12 answer, which I hope is correct. I'm not actually double checking. I'm assuming since I'm using computer, they should be able to do this correctly, right? If okay, so now finally write line, inverted quotations, bracket marks, lex and another quotation, and we say answer of this big expression. Control C, and I paste it, is equals to, then again plus, and I paste it. Now what's going to happen? Again, since it is a complex expression that contains plus and everything, it needs to be properly evaluated. If you just execute it like this, you run the code, we get an error. Why we should get an error? Minus cannot be applied to operation of type string. Okay, so what it is doing is it said, hey, because you wrote it publicly and minus sign, I understood that this is +2, which can be joined with the string, then +5, 15 can be joined with the string, but there's a division. So naturally, it will multiply these two things together. Okay, so this multiplication will execute first. No matter what, how we wrote it, this multiplication will execute first. Then it will, whatever is the outcome of this, will 15 will be divided by that answer. So this is going to be division. Then whatever is the answer of this, it will hold in the memory and it will perform 7 mod 2. Then whatever is the answer of this will be minus by this thing. So at this point, it's going to create complications. That hey, why minus? Because then we have a plus. So in terms of execution, plus will be executed first before minus sign. Just like multiplication is being done first, then the minus sign. Okay, so it's going to add this together, do this together, then finally in the end minus will be done. And in the end, because we have already concatenated everything, it's going to say, hey, I'm subtracting something from a string. Okay, so this cannot be applied. So minus cannot be applied on a string. Understand? I hope a little bit. If you need, again, I will let me explain one more second very quickly. In this way, multiplication is done first. Then whatever is the answer, division is first. Because they both are on the same line, multiply gets executed first, then divide, then modulus. Okay, so then we have a third answer for this. Then because now there's a plus and minus, the plus will get executed first. So plus means that will concatenate with this string, then with this string, then it's going to concatenate this whole expression with the minus value, and then this is where the problem occurs. Okay, so minus gets executed in the end. That is why in a proper way we need to first put this whole expression in brackets. Okay, that's why brackets are so important, and understanding the operator precedence and how they are working makes things a lot easy for you, that which expression is going to be evaluated first and what's going to happen. So this time we get an answer 3. I'm hoping that because I'm using the computer, it's giving me correct answer. I'm not doing the mathematics for myself. So this is how we solve and we try to understand, okay, how things are working, what expressions I can use and what not. Okay, so let me just come here, Control A, Control C, go back to my Word file, and this time I will just paste the code. Oops, let me just paste the code somewhere around here. Control V. Okay, so this means that we have solved the code program number 3 as well. Voila. So similarly, there are many other programs that I'm still working on, trying to create output and trying to find some programs from different websites. Trying to create a consolidated book that you can use to program and generate, practice and learn as much as you can. So hopefully by the end of this course, after the end of the day 4, I will be able to complete this, and I will share this module with you. Meanwhile, you have these 3-4 programs. Do work on it, and you can find many other programs from online. Again, ask ChatGPT; they can give you more good suggestions of programs that you can practice on. Okay, so I think that concludes this session. So let's move to user input. So that's all, folks. Today's session we talked about data types and typecasting, and now day 5 or day 4, I believe. Day 4, we're going to talk about user inputs and how we get user inputs, and then we're going to also delve into C# operators. Okay, my name is Dr. Shan Badi. Please subscribe if you still haven't. Signing off.